Alright, on the last portion of that, it got cut off a little bit. So in the next part of this problem, we missed a little bit of these things. Let's start off by doing this. Okay, we split up into 2 over n. Alright, so when we went to the, well, actually the first space would be 0. We go to the end. When you put 0 into the equation, you get 0. Alright, then the first width was 2 over n. So I put that into my equation to get the y, or the height, or the lengths. So 2 times 2 over n would be 4 over n. Right now, what I was talking about is that this second x would be just double the space, since they're equally. What I drew over here was to sort of show this in the past. Okay, if you had from 1 to 9, that's a distance of 8. Okay, and you split it up into 4 rectangles. Well, each of them would have a distance of 2. Okay, so for instance, if we went back to this to find my height, what you would do was, well, first of all, you would put 1 in, okay, and the 1 would give you what the height is, but then you would go to the 3, okay, which go into that to figure out what it is, and then the 5, and then the 7, and the 9. So what we have here is, because they're evenly spaced, each one's equal width. So this one, from 1 to 3, when you go from 1 to 5, well, that's a distance of 4. That's twice as big. Okay, and that's why we did it here, is that if the first one was 2 over n, the next one would be 4 over n, which is twice as big. And if each one was space of 2, then you go from 1 to 7, that's 6. Well, that's 3 times as big as, and 4, and so on and so on. So we put these in to get our y's, and here we have. Now, what we're going to do, we look at this, okay, if we did this continually forever, okay, we would get the exact area. So this is where we're going to take the limit as n is approaching infinity, and we're going to solve that. All right, I'm going to take a second to erase this. Alright, now, going from here, what we see, now 0 plus anything, that would go away. If we look at these, they all have a common factor. Okay, and with this, they all have a common factor of 4 over n. So what I'm going to do is factor out, take out a 4 over n outside, since they all have that in common. Alright, then we're going to ask ourselves, well, if I do that, what would I have to distribute to get the same thing? I don't want to change value. Well, 4 over n times 1 would give me 4 over n. And then 4 over n times 2 would give me 8 over n. And then plus 3. And if we would have continued to do more of these, the pattern would continue and be 1 plus 4 plus 5 and so on. Well, in the book, they'll give this to you, and I'll give it to you. We can actually come up with an equation. So if I put in values, it would spit out all the counting numbers 1 through 1 to infinity. So we're going to use that formula to insert it in here, and then we're going to solve for this limit to find the exact area. All right, well, we can multiply these. This would give me 8 over n squared. Okay, I'll insert this formula. As you'll find that in your book, they'll give you these. And the formula would be n minus 1 times n all over 2. Alright, now we're going to solve this. What we're going to do is, to solve this, we do it like we do any limit as approached infinity in the past. Okay, we can simplify this formula a little bit. You've got the n there, would cancel out, and you'd have n there. 8 divided by 2, okay, that would give us 4. Alright, so then what we have is 4n minus 4 over n. And we want to find, and give some space, we're going to need some room here in a second, as the limit approaches, as n approaches infinity. Now, if you remember in the past, what we did was we took our highest exponent in the denominator when we found the limits, and we divide it. Well, we just have n, so we divide everything by n. Okay. When we do that, in the bottom we just have 1, so that's going to go away. 4n divided by n is 4. 4 minus 4 divided by, put the infinity in. 4 divided by infinity, what is that approaching? That's just approaching 0. So we get 4 minus 0. We get that the area under the triangle would be 4. Now that seems very complicated, but we're going to use this formula to find areas under curves which are more complicated. Now, we go back to the original problem. What we have is a triangle where we went a triangle 2x. We look at this. Okay, this distance right here, what you would have is on the regular triangle from 0 to 2, 1, 2. If you put 2 into 2x, that meant that the height of this triangle was 4, and it had a width of 2. Well, we know how to find the formula for area of a triangle. Area of the triangle is just 1/2, the height 4, times the width 2. If we multiply this out, we get that the area of the triangle would be 4, proving that and showing that our formula does work.